Thank you, everybody, for coming. I'm super excited about this and this set of topics and also the amazing speakers. First of all, I'd like to thank Hockey Stack for hosting us at their beautiful office and helping us bring this conversation together. The format here is going to be pretty conversational. These guys have an amazing use case and set of tools to talk about. So we're going to do a little bit of intro. Who are we? Then a little bit of how did we get here, and then we'll get to Q&A. So again, thanks everybody for coming. I'm Ilya Tabakh. I'm the VP of Innovations at TensorWave. And so I work in helping and think about how to make some of this infrastructure more useful and work with really smart folks like Greg. And so the gentleman here. So I'll pass it to Greg to introduce himself.
Is it on? Okay, great. I'm Greg. I'm the ScalarLM Architect. I feel like I've written it, I don't know. The history of ScalarLM actually goes back to NVIDIA when I was working on CUDA. And we built this like prototype version of it for the first deep learning training cluster in the world that was deployed in Google Brain and then Baidu. And we had a first version of this thing. It was called Majel. It never really saw the light of day, but I feel like machine learning and deep learning are so popular, and it's been so popular, it's been really defining over the last 10 years, that I just keep building it over and over and over again. So we'll talk more about that.
We'll have Molham go next.
Hi, I'm Molham. I'm the CEO and founder of a company called RelationalAI. As you might guess from the name, relational, as in relational databases, and AI as in AI. We've been sort of at this, trying to bring sort of AI into enterprise context for some time, and really mixing all the tools that we've developed over the last 30, 40, 50 years, going back to operations research and solvers and so on, all the way to generative models and so on. So I met Greg when he was a PhD student at Georgia Tech. I went to Georgia Tech too. I'm computer engineer, electrical engineer, and tried to convince him to build support for relational algebra and GPUs. And just in a couple of months on a summer internship, he did that and ended up writing a paper about it. And anyway, so go back with Greg a ways. And I met Farbod a couple of years ago. Farbod works at AT&T, and he's star engineer there, and we've been doing amazing things with Farbod and the team over there. So I'm, in a way, you want to hear from Greg and from Farbod. You don't want to hear from me. I'm too far removed from the keyboard, but I will be here to cheer them on. So.
Hi, my name is Farbod. I'm a data scientist at AT&T, and most of my work is around post-training and pre-training, different architecture, different model at AT&T. And I like to advocate for open source overall. And most of the post-training platform we have at AT&T is closed source. And ScalarLM is the first one I've been trying to get to our network, which we finally was able to do it a few months ago. And I'm also very interested to do everything we've been doing with CUDA on AMD GPUs. We have done a couple of interesting use cases that I think we're going to be talking about it in the next 30, 40 minutes. And there is one that I'm very, very excited about. And yeah.
Amazing, yeah. And so, whoa, this got a lot louder. So the format we were going to try to go for a little bit is have Greg and Molham talk a little bit about how they kind of work together and integrate, and then give it to Farbod to talk about some of the exciting results and work that he's been able to implement. So maybe we'll start with that and kind of go to start with Greg maybe.
So this is a TensorWave training pod. This is kind of organized into racks of AMD MI300 or MI325 GPUs. There's interconnect, allows them to communicate and to perform distributed training. This is like the advanced version of what we used to do in the early days of deep learning training clusters. ScalarLM runs on this, so we try to unify training and inference so that you can train LLMs, immediately deploy LLMs, and take advantage of all the compute resources in a giant cluster like this. And so ScalarLM, it's an open source framework. It's built out of open source components. It's built out of Megatron Core, which is actually derived from our early work on Baidu. That was like the 4th generation. We use Hugging Face so that we can run any model in Hugging Face. And then we use VLM as an inference engine for inference optimizations. And yeah, I kind of, as Farbod is saying, once you have these building blocks, you can then build many different applications on top of that. So yeah, I think there's going to be some pretty interesting things, and we're excited to show you some of them for the first time ever. One of the nice things about, or maybe the hard things about running on a cluster like this is just managing all of the resources, like getting all the GPUs to work together. ScalarLM runs inside of Kubernetes. It's been really hard to kind of bring the two worlds together of cloud deployments, like the Kubernetes cloud app deployment, with high-performance computing, sort of things like Torque and Slurm. We actually have all of it running together, and so you can basically just install Helm deploy ScalarLM, and then it just deploys the entire software stack onto the entire cluster.
For panels like this, I'm always curious, who's a developer at the keyboard here in the room? Just a quick survey. Okay. Who's integrated a rack for a data center, like actually racked and stacked servers? Okay, so less people. And so like going through all that to connect the dots and make it perform is just so many disciplines. And when we're kind of getting prepped for this panel, I sort of talked about this being a really complicated interconnected machine, but to actually get value out of it, that's just a lot of things. And so just highlighting that for effect a little bit.
Okay, so there's a lot I could cover on this slide. So first thing I want to say is just explain the kinds of things that we help big companies do, like AT&T. So I assume most people here would understand the term like business intelligence. It's basically BI tools like Tableau and Looker, and they run on databases like Snowflake and BigQuery and databases like that. So it's really analytics in a company setting that are all about what happened. What were my sales last year by region, by quarter, by product type, et cetera. Okay? So that's interesting, and it's a big industry around that, but it's not as impactful as decision intelligence, which is more about like, what will my sales be of smartphones in the Northeast in Q4 by brand, okay? That's about something that hasn't happened yet. And then if you can predict and infer from everything you know about your business and your competitors and so on, what might happen under various scenarios, you can start thinking about, okay, well, if I change the price, I lower it, I get more market share, but I make less money per unit. Or if I increase it, I make more per unit, but I don't sell as much. Where should I set the price to make the most money overall? Okay? So this is decision intelligence. It sort of requires you to reason predictively, prescriptively with things like integer programming, linear programming. You have to reason using graph reasoning, rule-based reasoning, sort of stuff that a SQL engine isn't very good at. Okay? So how do you build such systems in a way that's friction-free? Well, we know that there are a few popular data clouds, as they're called, like Snowflake is the one that we're starting with. And they have 12,000 customers. They have many, many exabytes of data, large data sets across all those customers. They have customers like AT&T and most of the Fortune 500 and a lot of the Forbes 2000. And we thought it would be good to take our technology and bring it into that kind of environment. Okay? There's a lot to unpack here, but the bottom line is this ecosystem is committed to openness in a variety of ways. So the enterprise doesn't like to be dependent on Snowflake or Databricks or anybody, and so customers like AT&T and many others pushed towards something called open table formats. So you have Iceberg, Delta, you might have heard of these things. So now you're not locked into a database vendor because all your data is in an open format, and anybody's SQL engine can read it. There are also standards for catalogs so that you don't have to be locked into a particular vendor's catalog. There are standards, emerging standards for semantics. so that you don't have to have your business logic trapped into a proprietary semantic format. So the idea here is competition is good, and you want openness, and you want any enterprise to be able to take its business to whoever is going to provide the best overall experience. You also want, like in the Snowflake case as well, you want not to be tied to a particular cloud, Azure, AWS, GCP, all supported. And then finally, building on all this openness and this sort of, as Farbod said, we don't want vendor lock-in. We want openness around AI, around GPUs, around training and inference stacks, so that a vendor can't hold any one enterprise hostage. Okay, so when we found out about Greg's work in ScalarLM and the fact that it was open and supported multiple GPUs, we went all in on it, and we started building super alignment on top of it. Greg will explain what that is, and started working with AT&T on that. Okay, so the problem is decision intelligence, and the principle is openness, and may the best solution win, and let the enterprises decide, and not go approach things from I'm going to hold a gun to your head, and you have to use me because something is not movable or portable or whatever. So. Okay, so this is an example of the commitment to sort of open semantics. You see RelationalAI sort of highlighted there. Snowflake, Salesforce, a bunch of companies are starting to commit to this because the market wants it, so to go with the table formats and so on. And then the other thing that we do is, if you want to move to the next slide, I told you that Greg will introduce super alignment. So the idea here, I'll take very briefly, and maybe Greg can give you a little more color, is this consensus, going back to Ilya's talk at Neureps, is sort of where the big models from Anthropic and from OpenAI, they are very dependent on public data sets that come from the internet, and that is mostly tapped out. So people are starting to think about, like, how do I generate synthetic data from public data sets and so on. But the reality is, in the enterprise context, like when you think about AT&T or Goldman Sachs or JP Morgan or any big company, the language models, the public data sets, have very, very little information about how AT&T really works. And that's by design, because AT&T wants to protect its data and so on. So the core idea here is, if we're running out of public data, there's, 10-fold more private data. There's maybe a million-fold more private data about AT&T than what OpenAI sees or Anthropic sees about AT&T. And so why not empower these businesses to keep going and keep adding effectiveness and intelligence into the language models by post-training them with all the enterprise private data, doing it in an environment that keeps all of that private, which is the 2 slides ago, the environment that I showed you that has our assets and Snowflake assets. Again, a really, I think, obvious idea when you start thinking about it. If we're hitting limits on data, where's the data that we can't see, and how can we start deploying it? And this is a very complicated thing. It's not trivial to convert like relational data into tokens that can be used to train these models and teach them about AT&T or JP Morgan or whatever. Greg, I don't know if you want to say anything about that now.
Oh yeah, so really, I love this topic. So I spent a lot of time looking at sources of data. I think back when we were in Baidu and we discovered scaling laws, there was a researcher, Adam Coates, who noticed that, we can just take common crawl, like we can take all the text on the internet and feed it into one of these algorithms, and it's just going to keep getting smarter and smarter. Back then we had 50 million parameter models. They were able to write like a few lines of code, but the writing was on the wall that plenty of data. We should be able to scale that up, and then OpenAI, Anthropic famously did that to create GPT-5 and Claude. And so the recipe is there and it works. And we got really interested in this idea of like where are the other untapped data sources, and we started looking at Snowflake. But as Molham said, the problem of how do you kind of crack open the database and get it into tokens and get the again out of batteries, get the language model to learn all of the semantics and all of the beyond just the tokens. If you just export CSV files, the language model doesn't really learn from the CSV files. Although early customers, we had people try to do that. So SuperLime is the first time where we're kind of together inside of the relational AI stack. We actually have a recipe that takes Snowflake databases and converts them into something that the language model can understand. And so we're starting to see the similar scaling law as we feed it with more data. It just starts getting better and better. And I think this result that's here, that's in this blog that was last Thursday, is really interesting. It's the first time that this kind of algorithm, running on the software stack, we had to build out on top of giant AMD TensorWave clusters. It's starting to win benchmarks. It's winning the Spider benchmark today. I think it's still currently number one. I think it's still today number one.
Yeah. It's a bit fast. I just wanted to show the slide.
Yeah.
Okay, so yeah, this is the leaderboard. So yeah, together with RelationalAI and AT&T, we have a version of super alignment running on the entire stack that we just talked about that's winning. In my belief, I think this is the hardest current SQL coding benchmark. It's many researchers have kind of put this together, but it has hundreds of databases. Some of the tables have tens of thousands of columns. The programs that are being written, can be, tens to hundreds of lines. So they're very complex and difficult problems. And yeah, I'm just really excited to see all of this stuff working together now that we've, it's been many years to build out, all of the different layers that we've needed to reach end applications like this.
And I want to also call out Sudhya, Rich, who are also part of the team that worked on this, and of course Farbod, who actually got us going. It was his idea. Hey, do you want to try to win Spider? And we're like, yeah, okay, let's go for it. So.
Yeah, and what's actually, to me, super exciting about this is open standards ecosystem plus your sort of operationalized data set allows you to do something that you can't do. In many cases, large models are hitting walls because they don't have access, but a lot of enterprises do and can continue to sort of take that. And so even from a logical standpoint, it's an exciting opportunity. And then I'll go on to some of the other sort of impressive results you guys have been able to achieve. Maybe kind of going through this kind of quickly because I want to give Farbod an opportunity to sort of talk about.
Yeah, BERT is a much easier benchmark than Spider. AT&T, before we showed up, was doing well on that benchmark. They were number one for a long time using multimodal approaches, but not doing any training. So in the Spider benchmark, in principle, we can train a language model per database, per data estate. And again, that sort of specializes things. And so AT&T was already very good at this, and then working with us, we showed on the dev data, because BERT will not take a submission from us because they don't take a submission of a fine-tuned model or a post-trained model on a per database basis. But on the dev data, we were able to show better than human performance, which was nice to see, even though this is a much easier benchmark than, say, the Spider benchmark. So Greg, I don't know if you talk about that.
Oh, sure. And so this is just showing the scaling curves or the learning curves. Effectively, it's showing that we're able to translate more compute on the horizontal axis into the blue line in the middle of the average accuracy across, I think, 11 databases in BERT. So we're converting from the relational database, the structured data, into something that the language model can understand and it can learn from. And this is just kind of the building blocks of ScalarLM. I think one of my perspectives on this actually is that, I think there's a lot of attempts to enable inference frameworks for LLMs or training frameworks for LLMs and then to build companies around them. I think these layers, through stacks like LLM and Megatron and Hugging Face are just open source. They're really becoming commoditized. The open source quality is just amazingly good. And so I think there are opportunities for innovation, but I think they're for example, super alignment, or as Molham mentioned, the semantic layer, the reasoners. They're things that are built on or around this. They're not really, I see a lot of startups trying to build at this layer and build proprietary technology in this layer. And, we've gone back and forth on that, personally gone back and forth on that. And I think the community effects of open source are just incredibly strong here today. And so it's better to take advantage of that than it is to try to really reinvent the wheel on this layer.
Awesome, and this gets us to Farbod and kind of what he's been able to achieve through some of this partnership. So,
All right. I put this slide overall to explain most of the GenAI use cases at AT&T. We have a tool called Ask AT&T, which is our effort to centralize all the GenAI basically effort in one domain, one area. So if you want to do inferencing, if you want to do training, if you want to do deployment, if you want to do data curation, as long as it has something to do with language model, it comes through Ask AT&T. It's one way for us to centralize everything, and also it makes the security part of it a lot easier. So it's internal. Yeah, if you're even AT&T customer, you do not see this directly. And there's over 100,000 people from our 140,000 employee that they are using it day in, day out for different reason. And most of the fine-tuning use cases that I think one of them is going to be the last slide, it usually has shown us, besides the GPU cost, there is not much of cost associated with it. So there is usually a huge cost benefit if you just fine-tune a model over using a large language model. But to my experience, every single use case at AT&T always starts with the largest model available because they care about the performance to begin with. But once they start generating revenue, they care about reducing the cost. So that's the pattern I have seen over and over. And approximately, we have a little bit over 9 billion tokens a day processed because imagine we have 240 million customer and there's around 140,000 employees. So any given use case that goes to prod, it gets used by a lot of people. And I think since the last 2 years, we have a little over 910 million API calls in production. There is so many use cases in a stage that it takes time for us to evaluate it before we are feeling confident to push it to prod. We also have around 91 use cases that are RAG and fine-tune model. Last but not the least is from language model has provided coding efficiency around like 20% across the company. And there is a lot of tools that people use it, including Copilot or Windsurf. They just helps with coding. Yep, this is the very recent effort that we all did together. We fine-tuned a model with a ScalarLM on AMD GPUs. Just to explain a little bit of the background for this, whenever a network is down, we always want to understand what happened. And it usually has something to do with the last few minutes, or it could get signal from the last few hours. So there is a lot of network data, logs of every single tower that exists across the United States that we can actually see that. The traditional way of people trying to classify the reason of the internet speed is low is they train a classifier like XGBoost or random forest model. So essentially, we extract features out of the logs, we look at it, and we try to extract numerical features so we can pass it through a model like XGBoost. And that was the traditional way of doing it. A paper came out recently from Huawei company in China with Khalifa University in UAE or Saudi Arabia. They did a joint effort on providing evidence that a language model does a relatively good job going through the logs without you extracting the feature. So essentially, the idea was whenever you take every token to a higher dimension, every dimension of your embedding is technically the feature you're trying to extract. So what if you just allow the feature to be extracted and you just fine-tune? That was their idea, and they did reinforcement learning. We got this signal, and we read this paper, and the idea was we have a lot of data at AT&T, so what if we do the same thing ourselves? But again, AT&T leadership always likes us to prove what we are proposing is going to work. So this is an open source benchmark. A lot of companies compete on it, and we were trying to prove that a small language model can actually beat a large model like GPT-5 or Grok 4, or you can say Claude Sonnet 4.5. And initially what we tried was we just got an embedding model and we add a classification head on top of it to see how well does that perform. and then we just got an embedding model and we fine-tune it. The last effort that I think we did last week, and AT&T, they're really happy we are number one on this benchmark. We fine-tuned the language model. And the idea was these logs exist. And instead of you, again, extracting the feature, what if you just let the model decide what pattern exists within the data? And it was amazing. And we did, I think, ran 156 different models until one of them actually worked. And I believe we were using one cluster from TensorWave for a whole week to run this. And Greg and I had a 4 hours conversation yesterday over how can we make the training on this data a little bit more efficient. Greg made a good point that we can actually stack all the trainings together during tokenization, so there is more compute efficient. It did work. Everyone is happy. Next slide. Okay, this is the one that I'm actually very excited about. I had a conversation with AT&T CTO around 2 hours ago about this project, and there is basically a hidden fight, a hidden competition in telecom. Who is better in language model? Who is better in GenAI? There is multiple big telecom companies in the US. There's a lot in Europe. There's a lot in China, in Middle East. What is amazing about this project, all of these telecom companies, they all have come together, and we are trying to prepare data. We come together to basically post-train language model and embedding model to have a better baseline for the entire world telecom-wise. So we have 2 steps in this project. One is the short-term goal is post-training language model and embedding model in English and only text, because we just want to keep the scope small for now. The second stage, which is going to be in a year, 1.5 years, is to pre-train and also do post-training on text and image, and do post-training on English and Arabic. Some of the partners we have are very large telecom companies in Saudi Arabia and UAE, and they have a lot of interest for having a multilingual model. The goal is to set an industry standard within telecom that if you want to fine-tune a model, use this one that has already seen telecom domain, has seen telecom tokens, is familiar with the vocabulary, and then go fine-tune it on your own data. So instead of starting from Llama model, Gamma model, what if you start with a model that has already seen every open source data? It's a better starting point. And also, AT&T, it helps AT&T to show its leadership in GenAI worldwide. It's a goal our CTO has, and it really aligns with what we want to do. And the first milestone we have is in March 2026. The GSMA conference is the largest telecom conference in the world, and it happens in Barcelona every year. And if this effort becomes successful, because there is quite a good amount of model we have to fine-tune, if it actually works, we are going to be featured during the keynote speech, and I believe every partner involved, including REI, TensorWave, they all get to have a slot to talk to their CEO, to CTO, to have fireside chat. So if you can get the job done, there is going to be a lot of PR opportunity for everyone. And is there? Okay, and this is one of the internal use cases we actually use a ScalarLM for. This is not a benchmark. AT&T gets approximately 300,000 to 400,000 calls a day. It's our customer calling us for a given problem. And we have around 240 million people. We do care of what happens in those calls. Like, we want to know what is the conversation that is happening. And there is certain topics that we care more. For instance, if our competitor name in any way has been mentioned, we want to understand what is the context of the conversation. Is that person coming from that competitor to us, or they're leaving us to go to that competitor? Because finding out if a keyword has been mentioned is a simple search, but finding out the context around it, you need a language model. And initially, we use a ScalarLM to fine-tune Llama 3.1 8B. We also use NIM, NVIDIA stack, for fine-tuning. So we did fine-tune with both models, and we were featured during a LlamaCon Meta conference. And I think that's
so maybe we're going to go to Q&A here in a couple minutes, but I really want to take a second to have you guys reflect on the journey, right? Like when you guys were getting started versus where you are, and maybe a couple things that really caught my ear, and I'll put up some QR codes just so folks can scan them. One is that you were operating with models that have better than human performance, being able to run 100 plus concurrent experiments, you know, and then of course like concurrency and became still, you know, pipelining was still an issue. So that really caught my eye. And then just the scale of being able to deploy this effectively. But I want each one of you, if you would, just take a second to kind of reflect, you know, how did you get there? What was surprising? Where is this going? And then we'll turn it over to Q&A.
So it's really interesting for me to see the entire thing build from, you know, the data center, the GPUs, all the way out to end applications. I think what we're seeing here are some of the first, you know, applications that are deployed in production in enterprises that are built on top of a stack like this. So it's just to me, it's really magical to see things like working for the first time like this on a stack like this. I think the last time I remember a first time like this was we finally wired everything together in the V1 of the stack, which was deployed inside of Baidu, and we actually started serving live traffic on it. The amount of work that went into like all of the layer of the stack to kind of, you know, support an end application running an LLM like that, it was just, you can't imagine how many sleepless nights and years, man hours, and, you know, how many people contributed to this. But once it's there, you know, you can build anything on top of it. So I'm kind of excited to see what people build.
For me, it's just you know, whenever you're building a company, especially when you're smaller, it's just you're eager to make your customers happy and make sure that they see value in what you're doing, and then you grow your business. And just the satisfaction that I see, not just in Farbod's face, but with his management and, you know, Mark and Abe and Andy and everyone, is just giving them options, giving them the openness of it, the ability to determine their own destiny and not being locked in. The relief is really, I think we really differentiated us from others that were just trying to lock them in. And so I think, you know, we do more business with AT&T because of the openness than we would otherwise, especially at our scale. So it was you know, just good to see that kind of validation. And so we create value with our solution, but then making it so that people feel like they're opting in and not being forced in was fun to see. So
the most exciting thing for me is AT&T being able to have a GPU agnostic solution. And I'm really looking forward to work more with the ScalarLM. And I think the GSMA project that we're working on, it's a great example of to test everything using a ScalarLM on AMD GPU as a huge scale, because we have over 1 million training points. We want to post-train over 20 different models, different architecture. Some of them are dense, some of them are sparse. So we are going to be hitting basically every single checkpoint that you would during post-training. And it would allow us to, at a scale, compare performance of AMD, overall AMD GPUs and ScalarLM. I'm excited to have GPU agnostic solution. And I'm glad that I got to work with Greg on this.
Amazing, thank you. Let's get some Q&A going. I'm gonna walk around, just raise your hand if you want to ask a question, and then just state your name and your question, and we'll get it going. Anybody have a question? Yep, all right. Just state your name.
Hey guys, Ryan here. I have a question for Farbod. You mentioned that the model that you eventually started using after you fine-tuned it was a GEMMA model, like a 4 billion parameter model for the GSMA telco dataset. What are you guys using that model in production now at AT&T for a lot of tasks? And if so, what was the model that you were using beforehand? Quantifiably, like how much are you saving? How much faster is it, et cetera?
That one is based just an open source benchmark. So that model directly is not being used at AT&T. That was a proof of concept for basically AT&T leadership to understand whether our approach would work. And if it does work, we can train in our own data. Because the difference was the benchmark is around 2,400 training points. It's a small, you can do the experiment maybe in a week or two. But internal data, you have millions, if not billions of training points.
Can you say, I think the spirit of the question is, can you say about the use case that you showed, what you were spending on, big models and
cost-wise?
Yeah.
Great question. If I have to, I guess percentage was around 90%, but if you want to know the dollar value,
Maybe not, but 90%.
I kind of want to know the dollar value.
So,
Make sure he doesn't get fired.
yeah.
I think it's safe to say it's a big number, and generally, like as these applications scale, having the ability to deploy models in a performant and cost-effective way is like half the battle, right? So it's cool to hear like a real example. Okay, what other questions do we have? Yep. All right, and just please state your name and go from there.
Hi, I'm Ron Haberman. Also, maybe a question for AT&T, and not to go on a tangent, but I was trying to Google as you were speaking about the telco AI. I'm trying to understand if the goal of the project to do like true closed-loop operations. So look at both of the data from the network, configuration coming both from people as well as automated systems like SON and otherwise, and try to correlate that with network events to the point where you can actually go and revert states or use configuration to otherwise recover the network? Or did I misunderstand completely and the goal of the project is something else?
There are many subdomains in telecom, including 3GPP, O-RAN, 5G, and many others. And each of those have their own manuals. And those manuals are thousands of pages, millions of tokens. The interest is GSMA itself, without AT&T help, they have already tested inferencing out of the box from the largest model available. If you can go back to the previous slide, it might help a lot. The one with telelogs. Okay, so Claude is one of the largest model that was released a few weeks, months ago. You can actually see it 67% of the time on an open source benchmark. It can actually identify the problem for a low throughput or like a bad network. So the reason that there is so much interest in this project is because we've realized a fine-tuned model on RAN, on troubleshooting data would really help you. A 4 billion parameter model, you can fine-tune it on 64 AMD GPUs in half an hour to an hour. If you have the right data, you can have one model. And also, once you have 4 billion parameter, you don't need that many GPU to have it deployed and inference from, depending on your inference traffic. So essentially, the idea is we already have a lot of evidence from different papers, from some of the POCs we have done, that fine-tuning a small language model on different domains within the telecom industry does work. But we wanted to scale this project because there's so much document. And some of these documents are like Huawei itself, the company, they have their own telecom documentation. And AT&T has some. 3GPP itself had some. And the idea was, can we put together a team of, I think right now it's 300 to 400 people, to actually put together very high quality training point to post-train both language model and embedding model. And it has taken a good amount of effort in the last 2 or 3 months to put together that data. because it's a small amount of token, but it's very high quality. Because like one of the University of Texas in Texas, this guy has, I think, 10, 20 PhD students. They have been working on this for the last 2 months. They put 1 or 2 questions together a day, but there's 20 of them. They've been doing it for 2 months. So they were able to give us like a couple of thousand good, high quality training points, which really helps a language model understand the documents. And did I answer your question?
Identify the problem. At what point, if at any point, you see that problem getting translated into dynamic operations that will go back into the network with that knowledge and say, okay, I see, for example, a sector of a cell site not performing. I now know what I need to configure, in the Ericsson device, well, I guess Huawei is out, but some other device in order to bring it back to operations.
You need decision intelligence to make a decision.
Yeah, the actual use cases of this model in production, there is a variety of them. One of them you mentioned. So the model, after it's fine-tuned on open source data, we need to further post-train it on internal data. But I guess it would converge a lot faster because I already seen similar open source data, but the business use case is a lot different from this open source data. So to your point, one of the use cases that I'm interested in is with the FirstNet. It's the first responders. They were invented, I guess, 20-something years ago, and they are the network that AT&T deploys whenever a national disaster happens. We had this wildfire in California a couple of months ago. We had the flood in Texas. And that's a temporary tower they deploy to provide access to the first responders, including firefighters and a police officer. And we have a specific data for those towers. We have from the time they deploy it, we can actually look at the duration they need it, we can look at the capacity they need it, we can look at the throughput of that. Fine-tuning for that separately for the need they have, it's something we need to do after we do this open source fine-tuning. So this GSMA has nothing to do with internal any company data because we want to open source everything. We want to open source the input data, we want to open source the code, we want to open source the model output. We want to be very transparent. What is the input, what is the output, and everyone can replicate it as long as they have the GPU compute. So that one is, everything is open source. It has nothing to do with any company's internal business use case.
We're going to close it there. Just a couple housekeeping notes. We have an extra about hour of networking. We're going to wrap it up and get you out of here just before 9. And also want to, again, thank our hosts for the space, and Hockey Stack's been very generous, and it's a beautiful space. Also, it's just a quick comment to take the initiative here, but it's awesome during Open Source AI Week to hear about all of these things coming together and truly delivering impact through open source, right? And this is standards-based hardware, open source tools, integrated frameworks, and it's all of the, it's the entire band. And so excited to see the conversations that happen in happy hour, and thank you for coming out. I think it was a great conversation. And let's thank our speakers.